So good morning, students, once again. So let us start the session. Am I audible?
Yes, ma'am.
Is my slide visible to you?
Not yet actually for me. Hi, it came, ma'am.
Yes.
Okay.
Ma'am, also, ma'am, like anyway, quiz you are not postponing, no. So at least can this hour be given to finish lab programs?
What you are doing on Saturday evening, Sunday?
What, ma'am? Full day you will keep, and then teachers also won't leave, and then full weekend you will ask like what we did. Your wish, ma'am. Like anyway, those programs freeze, no, ma'am. So I was getting stuck. So still, some 1.5 lab is still pending. And tomorrow only your telling class quiz. And tomorrow it seems Saraswati Puja also is there. Sairam can put his request in front, or else we can probably give tomorrow itself. Anyway, Shiba ma'am is not there, no, ma'am. Oh, she's there.
Sriba ma'am is there and she will answer, I hope. I'll be
Okay.
starting the session. See, why students are depending on this 50 minutes, I am not understanding. If you have any doubts, then and there you could have posted it to the teacher and get clarified. Um, Surely you have a test tomorrow, so there is no second thought on that. Sriba, are you there? Ma'am is not there. Yeah. So students are asking something. So they want to do some lab experiments in this session.
Ma'am, if you're Priya, if you're having any doubt, if you haven't, that is like if you're partially done and you're not getting the output or something, you just post it and put it in my message. I'll see what is your error and I can rectify it. Other than that, I don't think giving an hour for only 43 people attending and wasting 1 hour is not feasible. So we shall continue with this class now. That is what I did because hardly 41, 45 people are there.
No, though this 1 hour is given for doing the programs, how many are really going to do? That is also a doubt. So there is no involvement, total involvement. Okay, so let us not waste this particular hour and let us proceed. And any doubts you can post your programs to ma'am.
Those
And
who have posted, I have given the solutions to them. What was their mistake, and I have reposted them with the correct solutions. Previous to previous lab, a few students were asking. I'm trying to clear their doubts. So like that, if you are also having any doubts, you can post it. I can try helping you out.
okay. So I think Priya, we will start discussing another topic. So the topic of today is how to represent sets as binary trees. So binary trees, we know that each and every node will have less than or equal to 2 children, right? The children may have, if a node may not have children or may have a child or may have a children of 2. So that is the definition. We already know in many previous year courses, we just discussed about the binary trees in data structure as well. So what is binary tree? No need to explain. So now if you take the binary tree and we are going to use the terms entry node, left branch, right branch. The entry node is a new word maybe to you. This is nothing but an element. For example, given a tree, the element can be a parent, or element can be a root. It can be a root. So in each and every tree, you will have node, a entry node, and you will have a left branch, you will have a right branch, and this definition carries recursively. So why we need to discuss about the binary trees? And so far we were discussing the sets using the list primitive and with the ordered list or unordered list. And the efficiency of the program can be increased if we are using a ordered list. That's what we have discussed. And the searching will be very easier, and we can achieve some a kind of better performance, right? We can write an algorithm with some kind of efficiency we can achieve if the data is in the ordered fashion. So now better than the performance what we were discussing with respect to the ordered list, if we are representing the sets in terms of a binary tree, we can achieve better than that. For example, binary tree in the sense, the efficiency, the rate of growth can be of log n, right? So that we can try to achieve. So now let us look at how to define a list as a tree. How to define a list as a tree. How to represent it. So let us look at, by knowing these terms, you will have a root node, you will have a left branch, you will have a right branch. And the left branch is nothing but the contents which are smaller than the parent will be in the left branch. The contents which are higher than the parent node will be kept as a right in the right branch. So let us look at this particular example. There are elements 1, 3, 5, 7, 9, 11. Can you draw a binary tree for this? Can you draw a binary tree for this? Is there any opinion on this? How to go about it? How to draw the binary tree? So we can take any node as a root node and we can start representing, isn't it? We can take 5 as a root node, or 7 as a root node, or 11 as a root node, even 1 as a root node. We can represent the data using the binary tree. But by having a constraint, all the values in the left branch should have a lesser value than the parent. And all the values in the right branch should have a higher value than the parent. So there are it is possible to draw many binary tree for the given set, isn't it? That means the root node with the root node 3, what will be with the root node 5, we will get a different tree. So let us look at one example. If you are taking 7 as a root, and for this particular element, this list can be represented like this. So 7, if you look at the left branch, you have a lesser value than 7. So 1, 3, 5 you have. If you look at the 3, the node 3, the lesser value is here and greater than 3 is in the right side. So look at this right side. So 9 is greater than 11 and 11 is greater than 9. So that's why it is in the right side. So this is one tree format if we are representing the list with root node as 7, isn't it? So let us take 3 as a root node. The binary tree, we will get a different shape, isn't it? And again, if you take 5 as a root node, you can just get this kind of binary tree. So now we are going to write an algorithm so that we are trying to write an efficient algorithm which will have a rate of growth of what is that, a kind of log n, isn't it? So now the case, suppose if you start with 1 as a root node, if you take 1 as a root node, how the binary tree will be looking like this. If you take 1 as a root node, I just take a pointer. I'm not getting the pin. Okay, just. Okay, so if you consider 1 is the root node, what you will do. So in order to draw the tree, what is the next element? The next element is 3. So 3 is greater than 1. So what you will do, the 3, because 3 is greater than 1, you will draw a node with 3 in the right side. And then we will take the third value. Third value is 5. 5 is greater than 1 and also greater than, because I am drawing something happens, just to look at virtually a tree. So 5 will be in the right side. If you go on proceed like this, 7, 9, 11 all will be right to each node, isn't it? So you will have 7 here, you will have 9 here, you will have 11 to the right of this. So you're going to get a skewed tree. This skewed tree is called as a right skewed tree, isn't it? So if you look at the length of the tree, it is length here. It is always the size of the tree or level of the tree, or I can say the tree height is going to be increased, isn't it? So always, if the tree height is minimal, we can perform the operations like searching an element and inserting an element will be performed in the efficient way. So in the case of a skewed tree, this is the worst case. If the tree is in the left skewed or in the right skewed, then the insertion or searching for an element will take more time. So whenever we are constructing a tree, we should go for the balanced tree. So now the concept of balanced tree, what is that? If you look at 5, see this third tree, if you look at the height at the left side and height at the right side are same, isn't it, right? So you have 3 nodes here, three nodes as a child, and here also 3 and 1, so nodes, 2 nodes further in the left side and 2 nodes. The level is actually it is 2. So if you consider 5 is located at level 0, and you have level 1, you have level 2. So level 1 and level 2 right side as well and the left side as well. So this is called as a balanced tree. So balanced tree concept also you know it, right? So now if you want to perform the search or insertion in the balanced tree, will be taking a minimal operation. So depends on the value what you want to insert. Suppose I want to insert 2, what you will do, go for the root node and then compare, and I want to insert 2 is less than 5, so automatically you will go to the left, right? And again you will compare with the parent, and the 2 is what? It is lesser. So then you will insert this side. Suppose if you are going for inserting 13 or something, then what you will do, right? So now here in the case of a 5, how will you insert? 2 is lesser than 5 and 2 is lesser than 3, and then go ahead, and 2 is greater than 1. So now you will attach to this side. You will be attaching to this side. So when you are adding 2, what happens is you are looking at only one branch, that is in the left side. If you are adding 13, consider 13, so 13 will be added this side. So you will be just doing operations on the right side. The comparison, everything happens in the right side. So in only one half you are going to work on. So the operations to be performed is reduced to n by 2 than n. So if you don't have a tree, right, and you have it in a kind of a list, and you want to perform the search operation, always it will take a big O of n. But the same thing, if you have the data in the form of a tree, then your operations reduced by 2. That's what I would like to say. So now, so given the list, and which one is the valid tree? Which one is the valid tree? So that means you will be always aiming for the balanced tree, isn't it? Okay. So if it is not balanced, the number of operations will be increased. So whenever you want to insert data, and you have to see to that the data, the tree what is formed, it should be in an equal height, that is with the minimal height, I can say. Okay, so the minimal height is achieved only in the balanced tree. Okay, so now let us define some procedures which will be helpful for constructing a binary tree for the given list. Okay, And also searching an element in a given tree. We will also can perform an adjoin operation. Right, there are many operations we can perform: adjoin, searching, and then intersection, and then union operations. Now let us look at how to make a tree and then how to insert the data. That is by using the adjoin. Okay, by using adjoin procedure, how to insert the data in the tree. Okay, so let's look at some of the preliminary procedures required for building a complex procedure. Okay, let us look at. Now, entry tree is the procedure. It is one of the procedure. This entry tree will be returning the entry node. What is meant by entry node? It will return you the car. And now we have an assumption that, for example, you would like to have values 3. Okay, so 3 this side, and then you want to have another element, consider it as 2 as a left child, and consider another element which is 7 as a right child. This is 7, sorry, this is 7. So given 3 as a parent and 2 is nothing but left child, and 7 is nothing but a right child. Okay, so now defining entry tree. Entry tree is a procedure which will return you the car of tree, which will return you the car of tree. So what is car of tree? Okay, so now let us have this particular tree. Okay, this tree I have drawn, right? And what is the equivalent list in the form of a list? Let us say I'm just going for this mode so that I can type in instead of drawing. Okay. For the given whatever I have drawn, what I have drawn, this is 3 as the root node, and then you take 2 as the left child, and then take 7 as the right child. Okay, considering this tree is already I built, but for which list I built? Okay, but for which list I have built? So what is the equivalent list for this tree? Okay, 3 is the parent and 2 is the left child and 7 is the right child. For this, if I'm writing the list, what I will say, the list always will have 3 elements. So if you look at a procedure here, I'm going to make one entry in the list. Then the meaning is I will be inserting a list with 3 elements. One is the parent, another one is the left node. What is the value of the left child, or pointed to the left branch and pointed to the right branch. Okay, so having this very small tree, how to represent this in the form of a list, how I will represent. So first of all, I will talk about the root node. So the root node is here, it is 3. I just maximize. Okay, so 3 is the entry node, and for which I have left child. What is this left child? It's a left branch. So in the left branch, you only have an element 2. And for 2, what is the left child and what is the right child? The left is what? It is nil. Right is what? It is nil, isn't it? So now for 3, the parent 3 and the 2, that is the left branch, I defined with the inner list, right? And now for 3, I have to write again the right branch. What is the right branch? Right branch is 7, and then for the right branch is 7, there is no left and right child. So I will be writing nil and nil. So this is the representation, right? So whenever you want to make an entry into the node, you have to have 3 elements in the form of a list, right? So if you take 3, 3 is the element, and for which left is this one. This is the reference to the left child, and this is the list or referring the right branch. 7 nil is the right branch. Okay, so now what entry node does? Entry node procedure this has to return you the first element. Entry node has to return you the parent, or in this case, it has to return you 3. Okay, so what is the entry node? Entry node has to return the car of. Suppose I say in the sublist, which is the entry node, it is 2. Okay, in the sublist, which is the entry node, it is 7. Okay, so always given a list, I should be able to retrieve the first element. The first element will be the parent. Okay, so car of tree. So the list name is a tree. So car of tree will return you 3 here. Okay, so for this example, okay, so but now I'm writing the common general procedure. Entry tree is the procedure which will always return you the car element, the first element in the tree. Okay, let's go for the how to fetch the left branch, how to fetch the right branch, how to fetch the left branch. You take this particular example. How will you fetch? This is nothing but a CDR. CDR is second element to the third element. But I want only the first element. I want only the, the second element in the tree, right? So CADR of tree. CADR. So you're applying the CDR operation and then apply the car operation so that you will get this element, isn't it? So this is what? This is not element 2. It is a left branch, isn't it? Branch in the sense what? You are just defining what is a branch in the left side. 2 nil nil, right? So the whole thing you are returning. Okay. So likewise for returning the right branch, you have to retrieve this 7 nil nil, isn't it? So how to do that? You are applying the CDR. Okay, you will get these two, and then apply once again the CDR. You will get the 7 nil nil, but actually it is in the list, right? So you have to retrieve only the inner sublist so that you have to apply the car. So CADDR of tree, which will return you this right branch. Okay, and then how to make a entry? So given a tree, I would like to make a entry. That means I want to insert a node with a 5. A node with a 5. So where should I return? Where should I insert? I have to insert. So I want to insert 5. So I will always check the root node. I will always look at the parent node. And this is lesser, but 5 is greater. So go to the right side and again compare with the 7, and 5 is lesser. So that 5 will be the left child. 5 will be the left child. 2, 7. So whenever I'm making an entry, what should I do? I have to create a list. I have to create a list with entry node, and then what is the left branch and what is the right branch. So here, if I insert 5, so list 5 nil nil I have to insert. Okay, so now these are all independent procedures. It's a very primitive procedures required for writing our complex procedures, for doing a operational searching and for making the tree, or doing an adjoin operation. Okay, so I hope you understood here. Entry tree will return you the car, and the left branch of tree can be obtained by using CADR, and the right branch of tree can be obtained by using CADDR. And whenever you want to make an entry, you have to create a list with the entry and then left child and then the right child. Okay, so this is what these procedures will be helpful for performing the further operations. I hope you understood. Let's move on to search operation. Consider there is an assumption that tree is already built. Okay, the binary tree is already built, and we are going to write a Lisp procedure for searching an element in the given set. Okay, so how to search? That is, element of set question mark is procedure name, and passing an element x and given the set. How to how to find out, how to do the search operation. So my set will be actually, suppose you have the elements like 3 to 7, whatever I told, 3 to 7 is the list operation, right? But in order to represent this list in the form of a tree, what you have to do? You have to key in the data. Actually, what I'm saying is this set, this set is not this one. You're not giving the input as 3, 2, 1, but instead you are giving the input as 3, and then the left branch is 2 nil nil, and then the right branch is 7 nil and then nil. This is the way you have to give the input. Okay, this is the way you have to give the input. This is a format. So now I'm talking about representing the list in the form of a tree. Okay, so the my format is this one. So this set is nothing but this one, not this one. Okay, 3 to 7. It is not 3 to 7. This is 3 and then a sublist for left subtree and another sublist for the right subtree. Okay, this is the input. Now let us take, I want to search for an element, consider it is 7 or 2, okay, whatever. So now what we need to do? First of all, the set is null. If the set is null, return false, it is not there. Otherwise, I will check for the car, the first element. How to retrieve the first element? We have already written a procedure, entry set, right? This entry set is going to return you the car of the tree. Okay, so now this x is equivalent to car of the tree, then you will just say, yeah, it is available. So you will return true, isn't it? So car of this list is 3, right? This 3 will be written, and you just assume that x is also 3 and the car of the list is also 3 and both are matching and it will return you true. Okay, the next condition is x may be lesser than the entry set. That means entry set is referring the car. So car is now 3. And suppose you consider that 2. 2 is available in the list or not. So x is 2. 2 is less than the car. Yes. So in this case, this code part will be executed. What it is, you are calling the same procedure by passing the value, but for the set, you are just passing only the left branch set. Okay, you're only passing the left branch. You're only passing the left branch, so it is sufficient, right? If it is lesser, you are calling the same procedure with the same, but with the left branch alone. So now this left branch, how it is defined in our program? The left branch is nothing but CADR of tree. CADR of tree. So CADR of tree for this CADR of tree is this one. You will pass the left branch. You may also have a sublist here in case you have many elements, isn't it? So now this is a simple case. 2 nil nil will be the set, isn't it? So now this sublist 2 nil nil is assigned to a set, and once again, whether it is null or not, no. Then car of the sublist is equivalent to 2. Yes, the car of sublist is 2 and x is also 2. You will return true. Okay, consider I would like to search for 7. Okay, so that means 7 is greater than 3. So in that case, you are calling the same procedure by passing 7 to x, but what? Right branch. You are passing only the right branch. So what right branch will do? That right branch will be substituted here. That means here 7 nil nil will go. Okay, and then you are obtaining the car, right? And car is equivalent to the x. Yes, x is 7 and the car of the sublist is also 7 and both are matching, and then you are returning true. This is the way internally the logic is going on. Okay, I hope you understood. So element we have also a written program for the unordered list and the ordered list. Now the list is represented in terms of a binary tree. Okay, so how to write the code? I hope you understood. Any doubt in this? You will not talk. You are in an angry mood because of not postponing the quizzes. Okay. So let me move ahead. Okay, let us perform a join operation. Considering the list is the tree is already built, the tree is initialized with some value, at least a root node, at least one node it may have. Okay. So now a join operation we also have done for the ordered and unordered list. So for unordered list, we just join the X value in the beginning of the list. But for the ordered list, we will compare each and every element in the set with X, and we will find a position. We will search for a position to insert X. Isn't it? So now in this case, the list is in the form of a tree. I would like to insert X. So where I have to insert, that matters. Okay. So now let's look at. You just see for 1 minute of how it is written, whether you can understand or not, and then let us proceed. Can you understand what we are doing? We are going to insert the value X in the set where set is represented in terms of tree format. Okay. So let us take this particular list, what we have discussed for this search. Same thing, let us consider. Okay. Let us say I would like to perform a join operation with the element 6. Okay, you have 3 to 7 and 6 is available. That means 6 has to be added here. So how this list will be transformed after inserting the element 6? So after inserting element 6, how the list, this list will be transformed? Any idea? Can you give me a new list? Inserting 6, what will happen to the list? And what will be the new list?
Ma'am,
yeah. Okay. Your voice is not audible, a lot of breaks here. Let us take this. Yeah. So now tell me, the initial case is 2, 3, 7. I would like to add 6. So 6 where it will be added? In the third level to the left of 7. This is what you are telling, right? This is what you are telling, isn't it?
Yes, ma'am.
Yeah. So in this case, what will be the new list? Where you will add 6. So for 3, this is left and then this is right. And for 2, nil nil only. But for 7, there is a left branch. So if you take this 7, the left is nil. This nil will go off, isn't it? In this case, I have given you a clue. 3, 2, nil nil. There is no disturbance to the left branch, but there is a disturbance to the right branch of in the right branch, but to the left of 7. So which will be affected? Left of 7 is this one. This is the left branch for 7, right? So instead of nil, you have to add a list. So that is, you have to make an entry, isn't it? This algorithm, this procedure you have to call by passing left and right. And we are going to make a list with 3 elements. So the entry is 6 and left is what, right is what. Okay, so now in this case, instead of nil, we are going to make a list, and the list with 6, and for 6, nil is the left child, nil is the right child. So nil and then nil. Check it out. Is it right? And actually this is also a list. I have to put a inverted quote. Is it right or not? After inserting 6, your list will become like this. For 7, the left branch is this one. Right branch I am not disturbing. Is it right? Understood, no? Students, tell me yes or no.
Yes, ma'am.
Okay. So now let us look at how to perform a join. So the insertion is what? A join operation, performing a join operation. So let us look at a join operation, and the set is null. Nothing is there. So that means it is a empty, isn't it? So the set is null. You can see it, right? Okay. If the set is null, then you have to make a tree with x alone, isn't it? And for x, there is null as a left child and null as a right child. Yeah, this is very, very explanatory, self-explanatory. The set is null. You would like to adjoin. That means you want to insert x. Consider the x is now it is 3. So how to make a tree? How to make a tree is you will call the make tree procedure by passing x value, and this is the left, this is the right. So that 3 and then nil and then nil. This is what you are creating. Otherwise, let us see. Another condition is the car of set you are taking, and the car of z is equivalent to x. The car of the set is equivalent to x. Then what you need to do? So now consider this is the available list, and you would like to make an entry with the element x equal to now x equal to 3. So what you are doing is you are fetching the car value. Entry set will retrieve your car value, and that car is equivalent to the value of x. Then return the same set because this is already available. So it will return you 3 nil nil. It will return the same. Okay. Let's go for other comparisons. X can be lesser than the entry set. In that case, what you have to do? X is greater than the entry set. What you have to do? This is the thing. So if the element to be inserted is, for example, it is 2, right? So x2 is less than the car of the null, then what you need to do? You have to do something. What you have to do? Make a tree. Make a tree means you are going to make a list, okay, with entry set and then adjoin set x left branch and then right branch. What it is? I'm not understanding. You tell me. Can you clarify this? What we are doing? If x is less than the car of 3, you have to make a list and then you have to what? You have to make it as a second. See, make tree what it does? Make tree is it is creating a list. make tree, it is creating a list. So what is the entry, what is left and what is right? Okay, so already some entry is there and the left is here. You have to insert. Suppose you want to insert a left child, this is the way you are inserting and keeping right child as it is. You are not disturbing the right child. You have to pass, you have to keep the right branch as it is, but you have to modify the left, isn't it? So that is what we are doing here. Make tree, okay, and what you are doing. Entry set, that is you are taking a car value and then adjoint set of x left branch of set. What it will do recursively, we are passing the value the left. Actually, in this case there are no left branches, so the left is nil. If it is not nil, what you will do, you have to once again make a take a car value, etc. You have to go to the bottom of the tree and then you have to insert. Okay, but you are what you are doing, you are just adding x as a left branch and you are not disturbing the right branch. Okay, if you look at this one, because the time is 4 minutes, we will trace it once again in the next session, but I am just giving you the logic. If x is greater than the entry set, you are just making the entry set and the left branch you are just keeping as it is, but you are joining in the right side, right branch. Okay, so now you're all in the mood of reading for the quiz. Okay, you just do it and let us do some research on this one by tracing in the next session. Okay, so and another question is, can you build a tree by using adjoint set procedure itself from the scratch? Can you create a tree by using the adjoint set procedure alone? The first element, I will make a tree, make a list, and then taking a second element, I will compare. If it is lesser, then I will make a node by calling this part of the code. And again, another value is greater than 3, then I will go for executing this part of the code. I will create, isn't it? So in this case, I can able to create a tree, isn't it? I can able to create a tree by using the adjoint set procedure. Okay, so we will discuss in detail with an example how the logic goes in the next session. Okay. Thank you, students. All the yeah.
Ma'am, tomorrow exam pattern, like how it will be? Should we code it completely, or will it be in the form of fill in the blank?
Fill in the blanks will be there. Partial code will be given. You have to fill in the blanks. You have to fill in the blanks. Yes.
Ma'am, a small request from us. Like we have asked everyone, most of them from our class, and most of them wanted it to be postponed, ma'am. Like, can you please?
No, actually, Sriba is the mentor. But it is not possible. We have already scheduled the quiz.
Like at least one day on Wednesday, can you keep?
No, Wednesday class is not there. I think you have to contact Sriba only.
Okay, ma'am.
Yeah.
Ma'am, the partial codes, will it be given in the AUMS or something, or directly only Teams and Racket?
In AUMS, partial code will be given, and for the filling the blanks, you may get the text boxes.
Okay, so many such questions, many such codes will be there, no, ma'am, or only one, like something like that?
It's for 10 marks, no, you may get 1 or 2.
Okay, yes, ma'am.
Yeah, in a single program, you may get multiple filling the blanks.
Yes, ma'am. Okay.
Yeah, very primitive level will be given in the code. You have to write. So the question, you just read it, and there are many, just a preliminary template will be given. You have to fill it.
And ma'am, I want to confirm the portion. So it is list and tree and then sequences. In sequences, like what all will be coming?
That is a Sripa portion, I think. It's better. I'll check with her and once again post in the group the syllabus.
Yes, ma'am, that will be good. Yes, ma'am.
Yeah,
Thank you.
we will confirm. Okay. So let's all wind up.